This is a video recording of the 8th grade lesson 1-8 in the Holt textbook entitled Solving Equations by Adding or Subtracting. Our objective here today is to be able to solve equations using addition and subtraction. So our definitions are as follows. Equation. Equation is a mathematical sentence that uses an equal sign to show that two expressions have the same value. And inverse operation, which are operations that undo each other, such as addition and subtraction or multiplication and division. Again, an equation is a mathematical sentence that uses an equal sign to show that two expressions have the same value, while inverse operations are operations that undo each other, like addition and subtraction or multiplication and division. Now, they'll have us getting formally into solving equations in just a little bit here, but in the first question, they're actually doing something a little bit different, related, but they're not actually solving. What they're going to do is give you potential different solutions for question number 1, and you have to determine if those potential solutions are indeed actual solutions to the equation. So let's take a look at that question. Here it's asking us to determine which value of x is a solution of the equation. Now, one thing I will point out before we continue is that what you don't want to do here is lull yourself into the mindset that there is always one solution. There is not always one solution. When we're looking at these questions where the variable is solo powered, meaning it doesn't have an exponent, usually you would only have one solution. However, as we go on through time and we work with things like absolute value equations or quadratics, those will or potentially could anyway have more than one solution. So don't lull yourself to believe that every time I'm solving for x there's always one answer, because eventually that will come back and prove to be false. Right now though, pretty much you will always just have one solution. So here we're supposed to determine if 5, 7, and 23, which of those three options is the solution to x plus 8 equals 15. So what you want to do is substitute each one of those numbers in for x. And the way you know you have a winner here is if the equation, or what you're solving for or working out on the left side, is the same thing as what you have on the right side. So in this first one, if I change x into 5, which is what they told me to do, it would be 5 plus 8 on the left side, which is 13. Well, notice the other side says 15. Since the left and the right side are not the same, that means 5 is not a solution. So we'll try it again with 7. Change x into 7. So we've got 7 plus 8 here. 7 plus 8 is indeed 15. 15 on the left side is the same as 15 on the right side. Since we have a match there, that means 7 is a solution, because when I plug 7 in for x, the stuff on the left side worked out to be the same as what we have on the right side. We'll finish with 23, but we know this isn't going to work. We can check it though. 23 plus 8 is 31. Well, notice the other side is 15. 31 is not the same as 15. So the solution to the equation here is 7. 7 plus 8 on the left side gives me 15, which matches the right side that also says 15. Okay, let's go ahead and go take a look at the next example here. In example number 2, they're asking us to now actually formally start solving equations here. And as you can see, the A example, which will be sliding up the screen in just a moment, says 10 plus n equals 18. Now, I think most of us have no problem doing that with mental math. But remember, not everything is going to be a mental math question. And indeed, in the homework tonight, you're going to start seeing some fractions and decimals right away, which will definitely complicate that. Okay, so first off then, we want to get the rules of solving equations back in your minds. I know you've seen this last year. For those of you watching at home that may not have had my class or may not have just participated in Westville schools during 7th grade, here are my basic rules for solving equations. When you solve an equation, you always want to put the variable on the left side. And when I say the left side, I mean the left side of the equal sign. This is not an absolute necessity, but the reason we always teach here that the variable goes on the left side is because when you put the variable on the left side, it's going to make inequalities much easier. which is what we'll be doing in just a few sections. The numbers, the constants, potentially coefficients if they're attached to a variable in future sections, but the numbers are somehow all going to have to get shifted to the right side. And when I say to the right side, I mean the right side of the equal sign. Now, there's a way we move things, and when we want to move things from one side of the equal sign to the other, we have to do the opposite. So that rule is going to be expressed by the saying opposite side, do the opposite. So for instance, let's say there's a plus 6, adding 6 on the left side of the equal sign. Doesn't matter what the variables. Let's say it's just k plus 6 to make it easy. I want to send that 6 over to the right side of the equal sign. Well, the way that you do that is by the opposite. Since it says plus 6, the opposite is going to be to subtract 6. But when you think about solving equations, what you want to kind of think about balancing a double beam balanced scale. If I take 6 grams off the one side of the scale and it was balanced to begin with, the only way to keep it balanced is to take 6 off the other side. And that's the same thing you do with solving an equation. If I subtract 6 from one side to make the number disappear, I have to do the same thing on the other side to keep that delicate balance of an equation. The other thing that you're allowed to do is you are allowed to flip the sides. You would flip the sides when you have more things in the wrong spot than the right spot. Generally, if they give you the variable on the right, and again when I say right, I mean the right side of the equal sign. If they give you the variable on the right side of the equal sign, that's generally a question where you're going to want to flip the whole thing. You just literally invert the left and the right side and then work through the rest of the rules. That will save you from doing opposite side to the opposite a bunch of times, which turns out to be more work than just flipping the two sides. Okay, so with those rules in mind, let's look at question 2, part A here, 10 plus n equals 18. So based on the rules, this variable is on the left side of the equal sign. That's okay. And this 18 being a plain Jane number, a constant really, that's okay on the right side of the equal sign. So the one thing that I have to get rid of here to make this work is the 10. That's a number. It belongs on the right side of the equal sign, not the left. Now, as far as doing the opposite here, you will notice that there is no operation directly in front of 10. There's an operation here, but that's really attached to n. Here's what I want you to think about. Usually we say, if it's an addition problem, do subtraction. If it's subtraction, do addition, so on and so forth. What I want you to think about here is just think about the signs on the numbers then, if you don't have an operation. 10. 10 is a positive number. What's the opposite of a positive? Well, the opposite of a positive is a negative. What does a negative sign remind you of? What operation? Well, it should remind you of subtraction. And that's why you see them subtracting 10 from both sides. Now notice what happens here with the 10s. I had this 10 and then I subtracted it off. Well, 10 minus 10 goes to 0, which is what you see in this third line, the first box. That's what should happen every single time. If you had 10 plus 10 there, you'd have 20 and you wouldn't have gotten rid of the number. Remember, the whole idea is to send the number to that right side so we can solve the equation. On the other side, I've got 18 minus 10. That's going to change into 8. And notice that this n is left behind on the left side. We get rid of the 0 in front. Of course, adding 0 doesn't change anything. So they're suggesting that n equals 8. Well, we can check that to make sure that that makes good sense for us by changing n into 8. And again, making sure that the left side equals out to the same thing as the right side. 10 plus 8 is 18. The other side says 18, and we have a match, which means we solve the equation correctly. Let's look at the B equation. You can see what's different about B other than some numbers and some variables. The key difference, the major difference, is that this one has a subtraction sign. So we're going to do the opposite here of subtracting when we solve this one. So we know we like to keep our variables on the left. Again, when I'm saying left, I mean to the left of the equal sign. And we have a number, 9, a constant, to the right side of the equal sign. So the one thing that's not so good there is the 8. 8 is a number, it's on the left, but as we know from the rules that you see in the upper right corner there, it's supposed to be on the right of the equal sign. So we're going to move 8. Again, when I move something, I do the opposite. So since this 8 has a big old subtraction sign in front of it, the opposite is adding 8 to both sides. So I add 8 to the left side and add 8 to the right side. And again, I'll say it again, when I'm talking left and right, I mean left of the equal sign, right of the equal sign. So on this left side, the minus 8 and plus 8 are going to cancel each other out, which is why you see a 0 here. Right? Think about it, if I cover up P, if it makes you feel better, it would say negative 8 plus 8 then. Well, of course that goes to 0. They're opposites on the number line. In addition, that always happens. So that's just going to leave me the variable P on the left side, but that's good because that's what I'm supposed to have. That's what I'm solving for. Over here, 9 plus 8 is 17. And again, we can check that. 17 minus 8 does equal 9. Since the other side says 9, the two sides check. Okay, here's question number 3. And in question number 3, it says, Jan and Alex are arguing over who gets to play a board game. If Jan, on the right, pulls with a force of 14N, what force is Alex exerting on the game if the net force is 3N? So, let's take a look at the different steps that are involved in solving the story problem here. It says in step 1, or in part 1, that the answer is the force that Alex is exerting on the game. Then what they ask us to do is list the essential information, the information that we pulled out of the question. Right? It says that Jan, on the right, pulls with a force of 14N, and it says that the net force is 3N. And those are really the only numbers they give us to work with in the problem. So what they ask us to do then is to write an equation and then solve it, where F is going to represent Alex's force on the game, and then we'll use that equation model. So as you can see, the equation they've set up is 3 equals F plus 14. Well, let's think about why this makes sense. They're saying that the forces together add up to make 3, which is what they mean right here when they are talking about the net force. Together, combined, the force is 3. Now, what they said here is that Jan, who's on the right, is pulling with a force of 14N, which is what's here in the second sentence. So 14 for Jan plus whatever Alex is doing has to equal 3. Now, this equation is written a little bit backwards from what we like, but it works. Look at what it says right here. The force that we don't know plus Jan's force of 14 equals the total force, which is 3. There's your equation that we're going to solve. It shouldn't surprise you that's what we're doing, because realize this section is about solving equations, so it wouldn't surprise us that the story problem has to do with solving equations. So let's take a look at the solving steps here, which is what you see right here. And notice the first thing they have is 3 equals F plus 14. Now, the book has decided to solve this question as is. We would not solve this question as is, because the variable is on the right side of the equal sign. And if you remember from the rules I gave you just a moment ago, we always like to have that variable on the left side of the equal sign. So this is the first chance we have to use that one rule that says that we are allowed to flip or invert the left and the right sides. And I want to make sure you've seen that before I set you free to work on the homework on your own. So what that's going to make this say, instead of 3 equals F plus 14, is F plus 14 equals 3. And that should work out a whole lot better for us, because if we go through the rules we said earlier, we said we like variables on the left. We do have variable f on the left, and numbers off towards the right of the equal sign, and that's 3. So the only thing that's not right now for us in our world of solving equations is the 14. Well, we can solve that now. Again, when we want to move something to the opposite side, 14 in this case because it's a number, and remember those all have to get kicked over to the right side of the equal sign, but right now it's on the left. What I'm going to do is do the opposite. So I'm going to subtract 14 from both sides. And again, when I say both sides, I mean both sides of the equal sign. This plus 14 minus 14 washes each other out, and on the right side there I just have 3 minus 14, which is negative 11. Which, in context of the question, remember, the question was asking us how much force is Alex exerting. So he is exerting a force of negative 11 where n stands for newtons. Alex is exerting negative 11 newtons on the game. If they go back and summarize it in the fourth step there, saying Alex exerts force to the left, so the force would be negative. Its absolute value is less than what Jan exerts on the right. This makes sense since the net force is positive, thus the game is being pulled closer to Jan. Again, they're simply stating there that because the number of jumps from 0 to 14 on the game on a number line is more than the jumps from 0 to negative 11 on the number line, right? Because that number of jumps at 14 is bigger, he's exerting more force. Even though the one is positive and the one is negative, it really, because of the way they're pulling left and right, it's simply which one has a greater absolute value, which is those number of jumps, not necessarily which number is bigger, because we know if we're talking about bigger and smaller, positive would always be bigger. Okay, so let's conclude this here with the check it out examples, questions 1, 2, and 3. In the first question there, much like the first example there, where they're suggesting different solutions and you have to go through and check to see which one is the actual solution. And again, you do this by plugging in that value for x. So I start off with 9. 9 minus 4 is 5. Well, that does not make the same thing as the other side, which says 13, so it is not a solution. Then we try 17. 17 minus 4 is 13. The other side does say 13, which means 17 has to be a solution. Now, as we talked about earlier, in this type of question, there is generally just one solution, but we'll check 17 anyway. 27 minus 4 is 23. 23 is not the same as 13. So indeed, we prove that there is only one solution in this particular question with 17. Now, while you see an answer on the screen for question 2, it does not match the work that you're going to have to do, because on the homework tonight you do have to show the work, the steps of actually solving the equation. What you hopefully notice right away looking at question 2 is that the variable is on the wrong side of the equal sign. It's supposed to be to the left of the equal sign. So this is, again, another opportunity for us to use one of those rules that you saw earlier that said we can flip the sides. So I'm going to rewrite this as y minus 23 equals 44. So let's apply the rest of the rules at this point. Variable on the left of the equal sign, numbers to the right of the equal sign. So we see the one thing that violates that rule is the 23. 23 is going to have to move. It's got to move to the other side of the equal sign. Well, you move something to the other side of the equal sign by doing the opposite. So since 23 has a big old subtraction sign in front of it, that means I'm going to add. So I'm going to add 23 to both sides. And these 23s will cancel each other out. Again, think of it as negative 23 plus 23. You can see that by covering up the y. So that's going to go to 0 and just leave me my variable. And over here I've got 44 plus 23, which changes into 67. And of course that is the solution we can plug it back into the original equation. We would do 67 minus 23 on this side, which does say 44. Since the other side says 44 as well, we've generated a match of the left and the right side, and that's how we know we've done this correctly. We'll look at the concluding example, which says Danny owns 58 DVDs. This is 14 less than Macy owns. How many DVDs does Macy own? So, Macy's quantity of DVDs that she owns is an unknown. So that is your variable, which I'm going to use X. The book would probably use D to stand for DVDs, but it's not a big deal. Now, look at what they say in the second line here. It's 14 less for Danny. 14 less than Macy, that is. Well, 14 less than X would be X minus 14 as an expression. And we know that X minus 14 is equal to 58 because that's the number that Danny owns. So the equation that we're solving here is X minus 14 equals 58. Okay, well, we can work with that. We'll use those rules. Luckily, the variable is on the left, so I don't have to flip the sides. So I'm going to say to myself, keep that variable X on the left, numbers to the right, 58 on the right. So we see right away that 14 is the troublemaker, and I'm going to move 14. 14 has a subtraction sign in front of it, so when I talk about moving it or doing the opposite, of course that means what I really mean is I'm going to add 14 to both sides, because that is what the opposite of subtracting is. That minus 14 plus 14 cancels each other out and just leaves me X. And on the other side, I have 58 plus 14, which is 72. Realize what 72 is. 72 is the number of DVDs Macy owns. That's what the question says. Third line. How many DVDs does Macy own? Macy owns 72. 14 less than 72 is indeed 58. And that's our check to make sure we did this correctly.